Today we'll analyze the region enclosed by the curves x equals 1 minus y squared and x equals y squared minus 1. Let's start by setting up our coordinate system. Since these equations are written in terms of x as a function of y, the parabolas will open horizontally rather than vertically. Let's graph the first equation, x equals 1 minus y squared in blue. This parabola opens to the left and has its vertex at the point 1, 0. As y increases or decreases from 0, x values decrease, creating this U-shaped curve. Now, let's add the second equation. X equals y squared minus 1 in red. This parabola opens to the right and has its vertex at negative 1, 0. As y moves away from 0 in either direction, x values increase. Let's find where these curves intersect. To do this, we set the equations equal to each other. 1 minus y squared equals y squared minus 1. Adding y squared to both sides gives us 2. Y squared equals 2. Therefore, y equals plus or minus 1. When y equals 1 or negative 1, x equals 0. So our intersection points are 0, 1 and 0, negative 1. Let's mark these points on our graph. Notice the symmetry in this figure. The region is symmetric about the x-axis. This means if we reflect any point in the region across the x-axis, we get another point in the region. The region enclosed by these curves is the area between them. We can shade this region to make it clear. This region represents all points x, y, where y squared minus 1 is less than or equal to x, which is less than or equal to 1 minus y squared. To summarize, we've found that these two parabolas intersect at the points 0, 1, and 0, negative 1, creating a symmetric region about the x-axis. This region includes all points that satisfy our inequality.